Okay, so on the Broker Workshop repository, you can open Google Colab. You can do it live or later, the Fink one, and you will arrive on this notebook, which will discuss solar system science in Fink. So each night in Fink, we label the ZTF public stream for solar system science, and our labels are twofold. On the one hand, we just gather known object from the Minor Planet Center, MPC. This is provided by ZTF, so we have nothing to do, just taking them and aggregating with previous ones. And we also tag for new solar system object candidates. So for that, we have a specific filters, series of filters that runs and try to basically identify new candidates. And we are about to link them, but I won't describe that today. So I will go over a few tools that we have. So this notebook is using the REST API of Fink. So this is something I quickly described in the first presentation via the science portal, but this is what is running under the hood. So first case study is known object from the MPC. So if you're interested in solar system science and you want only confirmed objects, you can get that. So we allow to query for any non-objects. So the nomenclature of asteroids or solar system object in general is a bit confusing. There are many standards, that's the problem. So here we use as much as possible the EAU number, but we also use, let's say, designation if the number is not there. So you have this weird nomenclature that we try to record at the beginning. So what you can do is just, well, do a post via the API, simple one. So here is the URL with the endpoint, which is SSO. And you can either use a number or a designation for asteroids or comets, for example. So if we run that one, like it will give you basically, data frame, pandas data frame. I mentioned that you can do exactly the same by AdSense portal. So under the hood, it's exactly the same that is running. So of course you can extract some properties. So for example here, so I took all the data from object 9247 and I'm just plotting its orbit, well, as seen by Fink. Of course, there are probably more than that. It's just like not in our database. So here it's color coded by MGD. By dates of observation, and you have the array and deck that is shown. You can also plot the light curve, so you can extract the data. So here is the light curve for the G band and the R band in blue and in orange, respectively. So it's the magnitude as a function of time. All the data schema is explained here. So you can follow this link. This is the link. So this is the URL for the science portal. And here you have this endpoint columns. So it's a get in the API, and you will have access by the description of everything that is contained in an alert. So you have, I don't know, hundreds of fields. So you have different categories in Fink. Well, at least we split the things in different categories. You have the ZTF original fields, which start with an I, the cutouts image start with a B. You have the Fink science module outputs, which start with a D. And so you have the classifier output, for example. And you have the added values. So those are even extra things that you can get. You can also make a query, well, a general query. So you can tell the system to give you all the solar system objects that are known in MPC and seen by Fink within 2 dates. So you can specify a start date, a stop date. So here I would query basically database, and I will ask at most 1,000 objects in between those 2 dates. So you can do that, into run. So hopefully it will take a few seconds, and then you can show all those objects. So here is basically a single exposure. You have a single exposure, and what I show is the position of this asteroid, or let's say solar system object in this exposure, and they are color coded by magnitude. So it's cool. So of course you can go further and extract some properties like the period, the axis, etc., etc. But that's not provided by Fink directly. We provide the data. The second case study, which might be of interest, is new solar system object candidates from Fink. So we have a series of filters that run just to try to select those that can be candidates. So we have basically 4 different cuts. So the alert must not be known in in the MPC catalog. It shouldn't be easily associated to a pan-star object. Well, there shouldn't be any prior detection, or at least one if it's within the last 30 minutes. And so, for example, typical ZTF night is like 300,000 alerts, and after those 4 simple cuts, very simple, we are left with a few hundred candidates per night that we just tag as a new SSO candidate. So you can query for them. So instead of solar system MPC, this time you have solar system candidates. So you can run this query. So here I query them between 2 dates. So give me all the candidates between 2 dates, and then we can plug them. Here we are. Okay, so this is the result, and this is color coded by feed ID. So feed are basically ZTF pointed on the sky. So this is in between, well, it's a 6-hour span. So you have many candidates and many different fields. And of course, now the game is to try to link those objects intra-night and then between different nights, to just try to reconstruct different new orbits. So we are doing that, but it's not yet released and waiting for production. So stay
Julien,
tuned
2 minutes, please.
Okay, excellent. Last case study is man-made object and space debris. So from time to time, when you query the data for solar system object or just like that, you end up with weird things like that. So here is a single exposure, and can you see the group of alerts at the bottom left corner? So if you zoom in that one, what you will see is just like a streak, discrete streak. This is a single exposure, so this is within the same exposure, and you have this object going like crazy. So, well, maybe it's an alien or something weird. If you look at the light curve, it's quite interesting because it exhibits some features. This is probably not calibrated, but you can see there's the thing. So here is a pseudo light curve. So it's the magnitude as a function of the position, the right ascension, because of course single exposure, so we don't have access to individual time for each alert. But what you can see is, well, I don't know if it goes right or left, but it's here, go fainter, brighter, fainter, brighter, fainter. So it's kind of a rotating light curve. So we think it's a rotating object. And what's most interesting is we have many of these objects every night. So we are investigating the population of this object. They are probably not solar system objects, even though they are within the solar system. So we'll tag them and release them. So stay tuned if you're interested. Those objects will be made available. Voilà, I'm done.
Great, very nice. Thank you. And we should continue. I think we're back on time, so why don't we keep going? And the Slack channel, I believe, is available for people to have questions and continue the discussions.